Okay, we're live. So, welcome to this week's episode of Saturday Morning Tonic, where we're 12 days, session 12, with 12 days to go. I hope I got that correct. I use Google. Anyway, let's get straight into it. That's what we're here for. Just a quick reminder that if you go to Patreon, you can get these questions ahead of time. Please do so. It's no good just listening. Sometimes you have to do it yourself, and best way to do that is to go to Patreon and download these ahead of time, have a go, and then come along to these sessions, or just have a look at the session once it's pre-recorded. So today we're looking at quadratics, probably the most important. I've saved it to this point for no particular reason except that was the order of sequence, but I think it's crucial. This topic is really important and I think you should master it. So we're looking at expanding, factorisation, the formula, completing the square, and lastly, discriminant analysis. So all of these will be revealed over the next minutes. I don't know how many minutes we're going to take, but let's do it. Okay, so this is, to begin, just basic skills. Expand the brackets in the following expressions and simplify where necessary. Okay, so let's just get this microphone in the right direction. First things first, I'm just going to give you all the wisdom so you don't have to make the mistakes in the exam. I think we'd all agree we want to make as few mistakes as possible in the real thing. It means we make as many possible beforehand, or we listen to some wisdom and trust it. When it comes to expanding this, we really need to do it separately and carefully. And that means appreciating that we write the brackets out properly, and this is called giving it structure, because a lot of people just write x squared plus 9 and think, wow, job's a good one. But unfortunately, that's not what it means. There are two brackets here. Everything in the left has to multiply everything in the right. That means 4 interactions. And I don't leave it to chance in an exam. I will do the proper box method. That's not the only way of doing it, but to me, in my experience, it causes the least amount of errors. Okay, so we can appreciate now that the answer is not x squared plus 9. There's a little matter of negative 6x. Okay, so we're adding all of those together. So this would be minus 6x in total. And there's our expansion, which is just this part here. So we can replace this. And we remember that negative 5 continues, and it makes such a difference when everything's in line. Really got to stress you to do that. Life-changing. And then we collect like terms, and there's the numbers at the end of the like terms. Okay, these two here, plus 4. Yep. Simplify when necessary. Well, what we just did was a simplification of 2 terms because we were collecting. But to be honest, simplification is also factorising. If you want to be 100% technical, I mean, the exam would probably only ask for this. But if we go ahead and factorize again after this, it might be considered more. The question is it possible? And the answer is not very nicely. We're going to leave it like this. Okay, so expand and simplify. This is where we have to be careful with negatives. Again, I really have to stress that using a box is going to organize things. So one length is 4m and a 3, and the other length is 6 and a negative 5m. I guess that's an important thing. This is a positive 6. There's nothing written in front that makes it positive, but this is negative, so it goes with the 5m. Okay, how do we approach multiplying those two? Well, it's 6 times 4, and then m times, well, just an m on its own, m times 1. Essentially, you're looking at 6 times 4 times m, and you can figure out that there's 24m. Okay, carrying on. I think this is why it's a little bit more tricky, because when it's not just a plain old x, you have to do two things at once. So 4 times -5 and then m times m, and -15m. Okay. You can see that the like terms are in the diagonal this way this time. So we often write the 20m squared first because it's their leading order. It's order 2. And a total like net m. So 24m take away 15m is 9m plus 18. There you are. That's the expansion. In fact, we probably want to write this the other way around. So I know it doesn't feel right, but having a negative on the front here also doesn't feel right to me. It feels less neat. And I think it's true that I've written one less sign, right? Because now I don't need to write the plus in front of the 18. So in that regard, it's simple. But expand we have done. Again, this is where we have to be careful that we do it properly. We write 2k plus 5 twice. We don't try and cheat this. And we do this one first. Technically, it's like 3, right? All right, let's write it all out as 3. But the strategy is that we can't multiply 3 straight away. That would be 3-dimensional boxes, and that's just not going to make much sense on the page. So we're going to do the first 2 first. And the way I explain it is, if I had 2 times 3 times 6, you wouldn't do all 3 at once in any situation, I can't imagine. You would do 2 times 3 first, which is 6, and then you'd multiply it by 6. So that's exactly what we're going to do here. So if we expand these brackets, we get 4k squared plus 10k plus 10k, so plus 20k plus 25. Now that's me doing it without the box method. Just hope we didn't make any mistakes. Sometimes you don't know you've not made a mistake, even if you double check. Stick with what works for you. Okay. Now we have a 3 by 2. I'm going to use the box now because this is not worth getting wrong. But if I were to use the arrow method, all you have to do, I would start with a 2 and I would say that has to multiply everything in this bracket, like that. And the 5 has to do the same, like this. So you have 6 multiplications, but just to organize that, I'm going to put it at the side. Like this. And do one at a time. So now I'm not going to miss one. Let's go. Sometimes it doesn't write, so this I have to rub it out because it went strange. Where is that? K squared, yep. And 100k and 125. Always got to double check that we haven't made an error. Maths is not about doing things quickly. I know it seems like it in the classroom, but it's not. It's about doing things neatly and efficiently, but also accurately. And it doesn't matter if you're rushing to do that. You're going to make mistakes. That matters if you do it with thought and you think. All right, I think we're good. And now we're going to look at like terms. So like terms and this are going to go across like that. Just a couple help us there, don't they? So 8k cubed. So this is a cubic. plus 60k squared plus 150k plus 125. And this is a descending power. Okay, so you've got cubed, squared, to the power 1 and to the power 0. We don't need all that, but this is the correct format that you can realize there's no simplifying needed, because you've got 1, 2, 3, 4 different groups, different types of algebra, and they cannot be simplified. There's no like terms here. Okay. Don't forget, if you have any questions, just let me know, and we can address them as we go along. All right, so expanding is the first stage to solving quadratics with factorising, because when you start expanding them like this, we're talking maybe, let's look at x plus 2, x plus 3, you'll start to notice that there's a relationship between these two numbers and the quadratic that ends up coming out at the end. And this fact is that the number is 2 times 3, and the coefficient of x is 2 plus 3. So this is why we start with this way round, because you start to notice these tricks, and this is how we sort of go backwards to put them in brackets. So without further ado, we're now factorising, which means doing the opposite of what we just did. So with these basic ones, where there's a 1 in front of the t squared, really the method is just a small table with the 36 as the focus. And remember last time we saw that the number at the end was going to be a multiplication of the two numbers that go in the brackets, and that's really useful to us. What possibilities exist for that? Well, two whole numbers that multiply together to get 36, they're known as the factor pairs. So we just go through in order. 1, 2, 3, 4, 5, 6, and 6. Nice. So it's going to be one of those. Bear in mind that because we're a little bit seasoned and we're wise to this, we know we're going to have something that looks like this. We recognize it's a quadratic, and I'll put an arrow to the thing that helped me realize. And then because of that, we're looking for two numbers that go in here. It's like that really helps us. So it's going to be one of these pairs over here, and either one of them work for 36, but we need to find the one that will also add up to this middle bit, which is negative 13. So out of these two, if we were to add or take them away, which one would give us 13? I think you can see this one works, and we'll just double check if any others work, because sometimes there are a couple. But 4 and 9. So now we've decided that 4 and 9 could get us to 13. How would you do it? Well, we'd have to go negative 9, and we'd have to take away a 4. So they both have to be negative. Well, thanks to the structure of this method, as soon as you've done this, these two numbers, in fact I'll give it two different colours, are what go in the brackets, straight as they are. So there's 4, and that will go there. So t minus 9 and t minus 4. If you don't believe or don't fully understand what just happened, or like why that works, you can expand these brackets. So t times t is t squared minus 9t minus 4t plus 36, and you realize that it's the same as the question. So this is an equivalent expression. So we have found the correct way to put it into brackets, and it works. So we've factorized it, we've added brackets, and this is the quadratic method. And this is the basic one. If you have a really basic quadratic, it's really cool. Start with this one. If you don't, then something like this requires a different method. So we'll get onto that now. There are other ways of tackling this. For example, your calculator. The calculator that I have is a Casio FX991EX. And if you go, just double check actually, go to menu. And then we're going down to equation. And then 2 for polynomial. And then 2 for degrees. You can then solve the quadratic. And then once you've solved it, it gives you sort of these. You can work backwards. But that's like a quite, I don't know, I probably wouldn't recommend that for the basic ones. That's if you're really struggling. So put a comment in the area underneath the video if you want to see a video on how to use your calculator at all times to solve all quadratics. There's a little bit of a method involved, but if that's your thing, then I can show you. Alright, so this one is a little bit more complicated, right? So we have to put it into 2 brackets. And we can't really use the same method as before because 10 might have some factors like this. But then we need to take into account the g, because it's not going to be a simple g and g like the other one. There has to be 7g squared, and the only way to get 7 is for it to be in one of these brackets. So there are combinations. It could be 7 in one bracket and 1 in the other, or 7 in the first and 1 in the other. But thankfully there's only 2 because this is a prime. So this one is clearly a little bit more complicated. And how do you recognize it? It's because this number is not 1. And how do we do that? I think the best way to stick to is the AC method, which coincidentally does work for the first question. So the AC method is kind of cool. If you've got a quadratic which is ax squared plus bx plus c, it's the coefficient of the x squared multiplied by the constant term at the end is what we're going to do first. So in this case it's 7 times 10, which is 70. Now we'll look at pairs for 70, which is as follows: 170, 2 and 35. You can probably start to see that you've got one already that works, which is 35 and 2. So we're going to now replace the middle term, 37g, with a combination of 2 and 35g. Now we probably want to put them together with what they're going to factorize with. So 35 as a common factor with 7, but 35 doesn't have a common factor with 10. So we're going to put that with the 7 first. You'll see what I mean. So 7g squared. How do we get to minus 37 using 35 and 2? We're going to take them both away. They're both negative. So just to prove that, negative 2, negative 35 equals negative 37. So we can replace it with negative 35g, negative 2g, plus 10. And now you'll see that I'll circle the two things that are the same. We just replace it. We write it in a different way. Yep, it's cool, huh? So now we've done that, we've thought a little bit about which way it goes around, we can factorize both sides again. So I'll put those two areas that we're going to factorize. On the left-hand side, 7 goes into both numbers. 7 5s are 35. And g, so we take that out, we get g, take away 5. You can expand that bracket and double check to see that it is correct. And on the right hand side, we're going to take out something as well. We're going to take out a negative 2. I need to take out a negative 2 because I want them to be negative in the bracket, but we'll see. So if we take out negative 2, that means that we're going to be left with g subtract 5. And the reason, when you divide by a negative, because factorizing is like dividing. So if I take a 2 out, I'm dividing by 2. But if I divide by negative 2, it's going to turn that positive 10 into a negative And there we go. So now lastly, we factorize in total. Just in case no one has seen this before, you have essentially one term here, and that is separated by a plus with another term here. Let's go into even more detail over here. I can write that 7g minus 5 as an addition of a negative 2 multiplying g minus 5. And that's what I mean by you have two terms. So let's just color that as well so you can see. And whenever you have two terms, you can factorize, right? So if I had 3x plus 9y, I've got two separate terms, green and red, and I can see what they've got in common, which is 3, and I can take that out like so. And in our case, what they have in common is a g minus 5. So g minus 5 is going to come out, and we're going to divide everything by what we take out. So what we're left with is 7g negative 2, which is kind of like the two numbers that are not in the brackets, but that's the way it works every single time. So now we've factorized something that probably would have caused us a lot of difficulty, but it gives, this is a method that you just have to roll with, you know, step 1, step 2, step 3. I didn't have to be challenged in an already stressful environment when I'm in the exam. Okay, so last one. It's a nugget. It's a golden nugget. You have to be able to do this. 16y squared minus 49x squared. This is a difference of two squares. Kind of looks like it, but then you're wondering about these numbers here and it's looking a bit messy. But you notice the numbers are also square. So this is 4 squared and this is 7 squared. And if you remember your laws of indices, if you had something like xy squared, then this can go, this expands in, like the law is that it applies to both of those factors in the bracket, so it becomes x squared y squared. And we can go backwards in the same way. So looking at this here, we're going to go backwards and say that that's 4y all squared. You can't deny that this is a square number because it's being squared. And this would be 7x for the same reason. It would be 7x all squared. And so we literally have the difference of two square numbers. By doing this, we've actually revealed the square root. So the method for difference of two squares is recognize the difference of two squares and then remember the format, because it really should be that quick. It's a trick. The format is the square root of the first term. So we get that out of the way. Let's say we had a squared minus b squared. We would square root this and it would go there and there. And we would square root the second term and it would go there and there. And one of them would be positive, one of them would be negative. Like, this is a generalization. So perhaps it looks a little bit complicated, but you're welcome to write that down and as a reference. But let's do it with our numbers. So we've got two brackets and we're going to square root the 16y squared first. And this has already been done. As we worked our way down here, we know that the square root of 16y squared is 4y. You just have to square root 16 is 4. Square root y squared is y. And that goes in the first two bits. Then we take the second one and we square root it. We've got 7x. So that goes in the second half. And then one is positive and one is negative. It does not matter which one is positive or negative. They're both the same bracket, aren't they? And they're both being multiplied together, which is commutative. It means it doesn't matter which way around they go. Okay, so where are we at? We've done our factorizing. Cool. Next. Solve the following equation. Fabulous. So oftentimes we have to equate the two, and we're talking about solving quadratics. You have to have them equal to something. Typically we need it equal to 0, because to solve a quadratic we are finding the roots, in other words where it crosses the x-axis. This is when y equals 0, so we need our equation equal to 0. So our first stage here is to get everything on one side. Get all to one side. In other words, equal to 0. I'm going to stick with 5m squared because it's already positive, so I'm going to add 4m squared to both sides. 9m squared. Okay, now I'm going to plus 30m to both sides. And take away 6 from both sides. Now there's nothing that I can divide through by. At this point, that if I found a common factor between 9, 30 and 25, I could just divide it through and it would be pretty sweet because it's equal to 0. So it would have no consequence on our answer, but make our numbers easier. In this case, we don't have that. And what you'll notice is this is not a straightforward quadratic. We can't just factorize it easily. It might be possible, but we can't do it easily like we can with the basic one, because this is 9 at the front. So we're going to employ the AC method. We're going to see if this works. Now it might be that this is like an impossible quadratic. It might be that we need a different method than the AC, but let's see as we go. Right, A times C. A times C is 9 times 25, which is 225. And now we want factors of 225. Might take a wee bit longer than your usual factors. It doesn't. 2 does 3 go into 225. All you have to do is have a calculator at the ready, and you can see rather quickly some factors that work. We're looking for 2 factors that could get us to 30. Okay. I don't think 4 are going because it's not even. 5 definitely goes in. So we'll skip straight to 5. Is that good? No, we're looking for 30. What about 6? No, 6 doesn't go. 7 probably won't. 8 won't go. 9 and 25. 9 doesn't fit with 25. So that's not a good one. Not going to keep going. 10 doesn't go. 11 doesn't go. 12 doesn't go. 17, 13, 14 probably doesn't go. 15, I have a feeling 15 does. In fact, it suddenly shoots to my mind that it's 15 squared, isn't it? So that's really cool. We've found 2 numbers that are going to get to 30 by the looks of it. So 9m squared plus 15m. We're going to using that previous method. I won't go into how it works fully because I've already gone through it, but this is what we're going to be using. You'll notice it's still equal to 0. That's crucial. Right, we'll factorize the left-hand side. We've got 3m. That's about it. So 3m plus 5. And also this side, what have we got? 5. We can take a 5 out. So that leaves us with 3m plus 5. Oh, perfection. How do I know that went really well? Because this bracket and this bracket are the same. That means that it's possible to carry on doing this method. We've got 3m plus 5 and 3m plus 5 equals 0. So in fact, this is a repeated root question, okay? So now we're looking for when is the left-hand side equal to 0. So that means we're looking for a value of m that gives us 0 over all. It's easier to think about this bracket by bracket. Because we're getting to 0, if either of these brackets was 0, then we get a win. And this is a little bit more tricky to think about. 3m plus 5, what should m be that it goes to 0? Probably don't want to waste time. So on the side, you're going to write 3m plus 5 equals 0. It's literally a question. Like, when is it equal to 0? Then you're going to use your rearrange skills. Take away 5 from both sides. Divide both sides by 3. And you'll find straight away, wow, look. That's the value of m that gives me 0. So m equals negative 5 over 3. As you can see, that's going to be the same in both brackets. So we're going to write repeated roots, okay? You're going to write repeat. So this is the one value that solves. For repeated roots, it means that this is going to just touch the axes. Okay, so in terms of everything, this is going to come down. Let's get this properly. There's negative 5 over 3. And it's going to come down and it's just going to touch at 5 over 3. Like, that's the one point that it touches. And we say that it hits it once on the way in and once on the way out. So it's like 2 roots. Should always have 2. But that's a little bit of background as to what's going on. But you should always have 2. That's why we write repeated. Okay, so that's solving. Put it equal to 0. You factorize it. And then it's kind of easy to do. Factorising is really important. Okay, next question. Solve the following equation using the quadratic formula. Well, at university maths, more often than not, you're going to be using the quadratic formula, trust me. Not quadratics that are easily factorizable. So this is a go-to. And if you're programming, it's really the go-to. So we're going to get good at it, and you'll probably use it a lot. So minus b plus or minus the square root of b squared minus 4ac all over 2a. Technically, that's equal to x, but who needs that? We know it's equal to x. We're solving. First thing is to identify a, b, and c. A is the coefficient of x squared. B is the coefficient of x. And c is the constant at the end, negative 2. Sometimes people think it's 2. Don't be one of those people. This is negative 2. The sign goes with it. So now we need to put it into the quadratic formula. There really is only one way to do this properly, and that's with plenty of brackets. So I'm going to rewrite this with brackets ready. And you want to think about what's underneath this root in 2 parts. Oh, don't want brackets. Sorry, I didn't want letters. All over 2, and I write little times there. Now, I've every now and again written a little extra for structure, like a multiplication. Now, we're just going to put these straight in. So b was 3, and it appears there as well. A is 7, c is negative 2, and a was 7. Okay, bit of working out to do. Now this is usually on a calculator paper, alright? The reason is this not very nice to get numbers out of. The numbers are usually very long decimals, etc. And it's usually on the calculator paper. But I have seen really nice numbers in here that you can do in your head. So be prepared that it could be on any paper. Watch out for the negatives. So 3 squared is 9. 4 times 7 is 28. Times 2 is 56, but that's negative 56. and all over 14. And here's our final simplification, negative 3 plus minus the square root of 65 all over 14. All right, so we've got as far as to say that this is equal to x. There's two solutions here. One that's positive in the middle, where addition, let's be very much more clear, it's addition, and one which is subtraction. So it's time to split the page. One where we have, is it going to save time? I don't know. I think it's better to not. Actually, I'll write it out separate. One where we have negative 3 plus square root 65 all over 14. And we'll call this x2, because I started on the right hand side for some reason. And one where we have negative 3, take away root 65 over 14. Okay, and for thoroughness, I'm going to be colouring this in. Jabbly lovely. All right, so put this in a calculator and then find out what we get. This, by the way, is x1. Shouldn't take too long. Minus 3 minus root 65 divided by 14. And it's going to give you like this decimal. It's going to say, well, it actually depends on your calculator, right? So, yeah, it depends on your calculator. But my one's giving me negative 3 plus root 65 over 14, which is a bit of a meme, where it's like, I put that in, so why are you giving me that as the answer? Press the S to D button. Because trust me, I don't make fun of the fact that the calculator gives you this, because it can be really useful for simplifying stuff. It's called the exact form. That's as best as you're going to get it written simply. But if you want to ruin the integrity of the number and turn it to a decimal, because let's face it, we don't really care about decimal places beyond 3 or 4, then you can write the decimal out, and yeah, that you get that by pressing the S to D button. I've noticed that some calculators call it the F to D button. I know that this means standard to decimal, but not sure what the F means. Full? No. Fraction? I bet it means fraction to decimal, but it's not always a fraction. Hey. So that's the first one. The second one is going to be exactly the same, but with a plus. So x2, and we'll skip the exact form, and we'll go straight to decimal on this one. Alright, I'll just type that again. Accidentally pressed equals. And I should have pressed S to D, because then it calculated it twice. Okay, without further ado, 0.36158, etc. I'm going to leave it like that, because you probably know when you need to round it. It'll say in the question, but this is as good as it gets. And hello, I'm from Vietnam. You can say hi. Hello, Vietchancha. Oh, come on, I've ruined that, haven't I? Have not said that correctly. How do you pronounce your name? Vietchancha. Howdy. Good morning, good evening, wherever you are. If you've got any questions, let me know. So this is how we do the quadratic formula. Be careful. Most important thing, brackets, BIDMAS, substitution. Be very neat. That's not neat enough, is it? There. Okay, let's move on. Solve the following equations by completing the square. So we have a broad range of completing the square questions, and they come in maybe 5 different flavors. You have 3 of them here, 3 of the main ones, and we'll talk through it. This one is the most beautiful one. It's where the coefficient of x is even. This is definitely a candidate for completing the square. Easy peasy. This is where the coefficient of x is odd. It's tough, but if you work with fractions, it's fine. But it just looks a little bit complicated. This is the most tricky one, where we have a number in front of the x squared. And we're going to look at all these three scenarios so that you're not worried about what happens, because it can all throw you off. When you go to the exam, no matter what happens, this exam is your exam. These questions are going to feel like alien. So they'll feel like you've never seen them before. The only thing you can do against it is see as many different variations as possible and build up your confidence in being able to tackle seeing new things. Anyway, without further ado, completing the square, like there's a lot to this. Give me 1 second. Needed a drink. Okay. Completing the square, there's a lot of theory about completing the square that's fairly unnecessary. We're looking to get an estimate for this. Well, not an estimate. We're looking for an equivalent form. But obviously we can't ruin this. This is an expression and we can't write something completely different. So we start by, I guess we could call it an estimate. If we were to write this in complete the square form, we're looking to have a few benefits of completed the square form. The first benefit is that, excuse me, instead of an x in two places, the completed square form only has one. That makes it ideal to go on and solve stuff. So completed the square form begins life as some sort of estimate. So we estimate it by halving the b coefficient, so x plus 2, or you could write 4 over 2, but we'll do this. Now, to show you fully what's happened is this is, let's say it's our best guess to begin with, it would be x squared if we expand this properly, plus 4x plus 4. And it's not bad, is it? We have the x squared, we have the 4x. But it's not accurate. It's told us, it's given us a plus 4 and we wanted minus 1. What's the difference? Well, how do we get to minus 4 from 1? We're going to take away 5. So if we adjust it by taking away 5, we can write this as our estimate form, which is x plus 2 squared, and our adjustment minus 5. Now, this is equal to our original question, but it's in a better format because we have just one x. And this is completing the square. This here being the square, but it had a little bit wrong with it, so we adjust it. We complete the square. I'm now going to show you how you do this without all of that background explanation, and hopefully you'll see it's quite nice and easy. So the first stage is to remember the format to begin with, which is x plus, should we write it in general up here? Yeah, let's do that. X plus half of the b coefficient all squared. That's how we first begin. So x plus 2 all squared. Now, rather than expanding it all, the only bit we care about that is always going to be different from our original question is where we get the numbers multiplied together at the end. We saw that it gave us 4, and that was wrong, and it's always that number. So all we care about is knowing this, like what the number is going to be when we expand it, and since it's squared, it's going to be this number multiplied by itself. So if we take away this number multiplied by itself, we reset this estimate to x squared plus 4x. It's plus 0, essentially. And now all we have to do is put the number that it should be, add the number that it should be, which is -1. So we take away 1. So this is a reset action, and this is put in the number we want. And what does that look like? Well, we're going to take away then that term that we halved squared, and we're going to subtract, we're going to add c, whatever it is. This, in this case, it's -1, but essentially, generally, we're adding. So let's write that down. Completed. This is to complete the square in general. If you're into that, that's roughly what we're doing, but it worked every single time. It's really good. We're going to use this for all of these questions. And what does this turn out to be? X plus 2, take away 4, minus 1, which is x plus 2, all squared, take away 5. And put it in a box to show you we've completed the square. Now, it says it's equal to 0, and I'm going to show you how we go on to use this. X plus 2 all squared minus 5 equals 0. If we were to rearrange the first question, this one, you couldn't do it. There's 2 x's, but you can do it. We've completed the square. We're going to move that 5 over. We're going to square root both sides, but remembering that gives us a plus or minus. And then we're going to take away the 2. So we have 2 solutions now. One where x1 is -2 plus root 5. And the other one where, let's write that again, -2 minus root 5. Actually quite nice. And if you compare it to the formula from the previous page, it does the same thing, but quicker, neater, and it depends. Less substitution, less bid mass, that sort of thing. So that's completed the square. That's the first thing that we can do. We've completed the square. The second thing we can do, and I'll highlight the form, like this is literally the answer, is this down here. The second thing we can do is find the vertex of a parabola. So this is a quadratic equation. In a graph, it looks roughly like a smile because it's a positive x squared. Okay, so this is sketching quadratics, and we'll look at this in a coming week. And since this is a parabola, we might want to sometimes find the lowest point on the parabola, like the minimum point. That can be very useful. And the completed square form allows us to do this. And I'm not going to go into it because when we do graph transformations, I'll go more into detail. But essentially, if we want the x coordinate of that vertex, we look inside the bracket here and we write the opposite number that we see. And if we want the y coordinate, we look to the outside where the number is, and it's exactly the same. It's not the opposite, exactly the same. So this is the coordinate of the vertex. I think because that is a positive, we will write that that is a minimum point, because you see it's right at the bottom of the vertex. You could have had a quadratic which is the other way around. That would be called a maximum. But this is the coordinate of the minimum point. All right, so I've gone into a lot of detail completing the square, because why not? These are all the kind of links that we should be aware of. Why would you complete the square? To solve it or find the vertex. Okay, or if you're told to do it, you know. Now this is where it gets a bit difficult, because how do you half this? Well, it's going to be a fraction. Most people turn to decimals. My goodness, unless you've got a calculator, I would steer clear of them. So I'm going to stick with fractions. Let's use that method and see how powerful it is. X plus half of that is 3 over 2. Don't be afraid to write 3 over 2. Nobody needs you to go into decimals. You just write 3 over 2 and you're done. Okay? And then we're going to take away this number in here squared. So we're going to take away 3 over 2 squared. And it's always take away. Even if this is a negative, it's always take away. And then we're going to plus 3, because this up here is plus 3. Let's work it through. X plus 3 over 2 squared minus 9 over 4 plus 3. And maybe we don't want to write 3 because we know this is over 4. We could write 3 as something over 4. Well, that'd be 12, wouldn't it? And now without a calculator, we can add these fractions because they're a common denominator. So we get x plus 3 over 2 squared minus 9 plus 12, which is plus overall 3 quarters. Now this is not solvable at GCSE level because if you put it equal to 0 and then move it over, you'll get negative 3 quarters. Don't worry about it not being solvable. Not everything is at your level, but one day it will be, because if you study A level, you'll get given a method. But now you need to square root a negative number, and hopefully you've seen enough on your calculator that square rooting negative numbers gives you an error. So at this stage, some people might be shouting out, yeah, but I know how to solve that when it's negative. Good, but at GCSE, don't worry about it. So it's not about solving this, but it's still possible to find the vertex. Note that this is a positive x squared, so it's going to be looking like a smile. So where's that minimum point at? Well, let's get rid of that for now till we know where it is. As I said, we go inside the bracket and make it negative, so it's at negative 3 over 2. And then on the outside, just as it is for the y coordinate. Right, let's do this. Negative 1.5, positive, there we go. It's up there. So this is the coordinate of the absolute minimum point of this graph. Hey, what did we see earlier? We couldn't solve it, okay? The reason it doesn't cross the axis. When you're solving a quadratic, you're finding the point where it crosses the axis. There's root 1 and root 2, x1. I'll call it x2, x1. They're literally the x coordinates of where it crosses the axis. This graph does not cross the x-axis, so it doesn't have a solution, and that's okay. But we can still use this to sketch the thing, because that can be useful to prove that it doesn't have any solutions, or you may just want to sketch it for any other reason. The last is where we have a number in front of x squared. And this is really difficult because our method that we just developed for completing the square doesn't quite work. What we need to do is put it into the format for when that it does work. And the way to do that is to factorize out the 3 from the front 2 terms. So if the 3 comes out, we're left with x squared minus 4x in the bracket, and then a plus 7 can just stay as it is. Now our job is to complete the square on the inside of this brackets. Okay, so we're going to complete the square on the inside. I'm going to get rid of that so we have more space. In order to do this, I'm going to open a square bracket, a big square bracket, to complete my works in. And we still have our plus 7 on the outside, okay? So let's see. To complete the square on x squared minus 4x, we have to halve the b terms of x minus 2 squared. And we go back into our automatic mode where we take away this thing squared. So we take away minus 2 squared. Thankfully anything squared is positive, but we'll still write negative 2 all squared, so you can see. And there's actually a plus 0 here, but that means we're going to add 0, but we don't need to write that. So it's really nice when there's not a number at the end. What you'll find is that x minus 2 all squared is x squared minus 4x plus 4. So we need to take away that 4 in order to get our x squared minus 4x. And that's what this thing is here. This is take away 4. Right, let's go. 3 x minus 2 all squared, take away 4, plus 7. Now what's in this big square bracket is equal to this up here. So we've written it where there was 2x's, we've written it with 1x. That's the main aim here. And now let's put this 3 back in. There's 2 terms inside this bracket. We're going to multiply both of them. 3x minus 2 all squared, subtract 12 plus 7, and we'll tidy up with minus 12 plus 7, which is negative 5. And this is equal to, well, this is just as it is. This is completed square form. Now the original was a positive quadratic, so it's smiling like this. So to find the minimum point, what do you think it is? Is this 3 going to change things? So you look inside the bracket and we see that it's like an opposite we want. It's going to be a minimum. So it's the opposite. So is it going to be 2 or is it going to be 6? Because maybe you have to multiply it by this 3. Actually, this 3 has no effect. Okay, so it's just 2. And then this is where we go for our y coordinate, and it's literally as it is. So we found the minimum point. We can sketch this really quickly. Positive 2 minus 5 is down there. So actually, from this diagram, I can see that it's going to cross the x-axis twice, meaning that there's 2 solutions to this quadratic. I could be interested in solving it. If I only had the factorized form, the question doesn't say put it equal to 0, but if I had to solve it at this point, I'd put it equal to 0. I would then move the 5 over. I would then divide by 3. I would then square root, remembering to plus minus, and then move the x over, the 2 over. So it's 2 plus or minus the square root of 5 over 3. I don't like that. I'm going to write it again. There. So one option is where it's 2 plus root 5 over 3, and the other is x2, where it's 2 minus root 5 over 3. This has gone into more detail than I intended, but I feel like since we're on that path anyway, here's a great reference for you, and you'll take this information. I hope it will be really useful to you, and it'll empower you to know what's possible and what you can do. So take my lead on this, and these are really good to do. Whenever you're doing completing the square, go the full way, and it's good practice. All right, we've completed that page. On we go. So this is, question 6 now. So let's, can I move this up? Yeah, so question 6. It says without solving. So how do you do that when, you want to know how many solutions it has? Well, there's a part of the quadratic formula called the discriminant, and this is discriminant analysis. So discriminant. Okay, now you'll recognize it from the previous slides or previous work that we were doing today as the bit underneath the square root. Okay, now it's really important here because if the answer to b squared minus 4ac, let's say it was negative 2, that's going to be an error. Okay, because you can't square root a negative. So in this case, we see that there is no roots. Let's say that the answer was 0. This in this case would give us repeated roots. The reason is because if this is 0, it gets rid of the plus minus, which means there's no 2 options to it. There's just one number. And if it's a positive number, let's say positive 10, then we say that there's 2 real roots. We can then tell how many roots this thing has, right? It's only going to have 2. whether that's repeated or not, or it's not going to have any. So we're going to use discriminant analysis. In fact, should I keep that there? Let's keep that there for, let's generalize this, negative, 0, or positive. And in those situations, that's what we're going to do. So let's do the actual method down here. We have to decide what B, A, and C are. So in this case, A is 17, B is negative 1, and C is 2. So that would make B squared is minus 1 squared minus 4 times 17 times, so 4AC, which is 2. Yep. What is this? It's 1 take away a very big, well, it's probably not big, but it's bigger than 1. And I don't need to go much further to realize that it's going to be negative. And it's pretty badly negative. So how are we going to conclude this? Well, since B squared minus 4AC is less than 0, because it's very much less than 0. Don't write this though, it's not necessary. Then we conclude that well, this little symbol here means therefore, say that a lot, there's no real roots. So this equation, how many solutions? None. And that's for GCSE level, okay? We don't want to go into the fact that it does have complex roots in a different plane. That's not for GCSE. But that's also a very beautiful mystery to discover if you want to go on and study A-level or level 3 mathematics. Further maths, that is. You don't get it on the standard prescription for mathematics. You have to delve into that a bit, but it's fascinating. All right, so that's discriminant analysis, because we're using the discriminant to see how many solutions this has before actually solving it. It can be useful if you don't want to go through those long methods. And beforehand, you can just see, is it actually worth seeing if it can be factorized before actually doing it? All right, cool. Last one. The diagram below shows a pond surrounded by a path of uniform width whose area is 41.25 meters squared. Find the width of the path. Okay, while you have a quick look at that, I'm going to take a drink, and I'll be back in a second. Yeah, need a drink sometimes. All right, so this is a real life question. I've not done this question. I made it up, and I think it's quadratic-y. But let's see, shall we? Okay, so the diagram below shows a pond surrounded by a path of uniform width. Okay, so its area is 41.25. So the area of the pond is 11 times 15 to begin with, which is 165. Cool. And the area of this path is 41.25. But how do we even know the area of that pond? Path. I think that's our focus. So the path area is the focus. I think if we found an expression for the area of the path in terms of the width of the path, we would then be solving for the width of the path. So I think the variable here, x, has to represent the width of the path if that's what we have defined. Makes sense, doesn't it? So let's label it on the diagram. And welcome to an important skill, is labeling the distances that you want to know with a letter, your favorite letter, but I'm just going to use cliche X. Anything else to say about that except it's uniform? Do you know what that means? That means that it wears a hat when it goes to work. No, it just means that it's the same width all the way around. Okay, that's the essence of uniform, everyone wearing the same thing. And it means that it doesn't matter where you go around here, it's always X. And that's kind of useful, I think. Well, I think that if we did the big rectangle, take away the small rectangle, that we would have the area of the path, wouldn't we? So the big rectangle is going to be this width here, and I'll write it in 3 stages as I see it, which is X, X, and 15. So the length of this pull is 15 plus X squared. X squared, silly Billy, 2x. 15 plus 2x in that direction, yes? And with a little bit of digital magic, we get space. This way is very similar. Got 2 x's, but instead of 15 we have 11. So the width will be 11 plus 2x. So that would be the area of the big rectangle. Agreed? I don't know what that is yet, but that's how I'd find it. And then we're going to take away the center part, which we've just found up here, which is the area of the pond. And that will give us an expression for the area of the path. And we're told that the area of the path is equal to 41.25. So we have that 15 plus 2x, 11 plus 2x, take away 165, equals 41.25. Well, the numbers don't look very nice, do they? I've done as much as I can with this diagram and all this information, so it's time to take it somewhere else with some space to churn through the algebra. So what are you going to do first? Did you think to expand the brackets? That would be really good. So 15 times 11 is 165. Yeah, 165, and we'll put it in one bracket so we don't mess up. 15 times 2x is plus 30x. 2x times 11 is 22x. And 4x squared. Take away 165 equals 41.25. Okay, that's not too bad. The 165 and the 165 look like they're going to cancel because they're all addition and subtraction now, so we don't really need the brackets. So we've got, let's put the highest one first, 4x squared plus 52x equals 41.25. And remember, this definitely is a quadratic, right? So you can see that this is a quadratic by the squared. And to solve a quadratic, do we remember that we're going to put it equal to 0? So everything needs to be on the same side. Okay, let's ask ourselves some questions. Does this look like the kind of number that you could find factors of? factor pairs. Not really. Okay, so you're going to be some absolute genius to do all this in your head. So we're going to rely on a method. Okay, so we're not going to try and factorize this into brackets. In fact, the number of things we would have to test would take us so long, because there's no real logical way to jump to it. Plus you've got the 4 in front of the x here, so I wouldn't even do the AC method, because 41 times 4, 41.25 times 4, it's a bit much, isn't it? I mean, maybe it works, because like 4 times 0.25, and then you've got factors of 165. I mean, it could work. I just feel that at times like this, where it doesn't look nice for whole numbers, that we should use the quadratic formula. And we just practiced it, so let's see how easy this is. And don't forget that you have the ability to use a calculator, and that can solve this in seconds. And that's what I will be using to double check my answer. And in that time that I told you to explain to you that I'm going to use a calculator, I've solved it. So I'm just going to write the solution down, because we don't really care about the solution, we care about the method. If a calculator does it for us, that's great. But let's see if we can get to this using the quadratic formula. So minus b plus or minus the square root of b squared, so 52 squared, subtract 4 times AC. It's very crazy in that bracket there. And that's over 8. So I've skipped quite a bit there. I'm going to go to my calculation mode on a calculator and type in 52 squared, take away, open bracket, 4 times 41.25, close bracket. So we're getting there. We're slowly honing in on this, even though I wouldn't like to do this in my head. Because, you know, just if you don't have my calculator, you might have a calculator that can't do quadratic solving. You still have a calculator. So what I'm doing here with basic multiplication is just something you could do with any calculator. Let's split the page at this point, because having a calculator, we don't need to do much. Plus 2044 all over 8. x2 is minus 52. Take away 2044 over 8. Let's check it out. What are our two solutions? Well, is it going to be a surprise? As long as we don't type anything wrong, we're definitely going to get what we already know that we're supposed to get. It's just going to be reassuring to do it. Minus 52. And if we don't get what we think we're supposed to get, then we can double check with an error. Okay, so it does look as though it's different, unless that is 55 over 4. 0.848, 55 over 4. No, it's definitely different. So I got something wrong somewhere. We'll just have a quick check. So that's A, B, and C. Minus B, good. I assume there's nothing wrong with this. No, there's definitely nothing wrong with this, because I've already checked that in the calculator. So B squared minus 4AC all over 8. Okay, let's double check. That's over 2A. That's definitely correct. 52 squared equals, take away 4 times. Oh, did I write negative 41.25? I bet I didn't. Yeah, that's better. I think that makes a lot more sense. Although it's not the nicest number. I wish that it was the other one. I think I've accidentally opened up a different break. Hold on. Whoa, did I just start? Okay, good. I thought I started a trade. How's that possible? I swear I didn't press anything. All right, let's keep going. 2, 5. 52 squared, take away 4 times 4 times negative 41.25. That was definitely where I went wrong, because that's actually 3364. And that's why we double check this stuff, right? And that's why it's good to have a calculator with us. So 52 plus the square root of 3364 is 6, which is 3/4. We knew that from our other thing, so it's very reassuring to see it. Negative 52, take away the square root of 3364 is negative 110/8, which is negative 55/4. All right, so there we verify that we've got to the correct answer. This is triangulation, isn't it? So when we do something one way and then we do it a different way and it leads to the same conclusion, that's triangulation. You have multiple things confirming your result. All right, we're done. We've got to the end of everything quadratics, and I consider these to be the defining skills needed in quadratics, which I consider the best and most important topic of all the GCSE. So this is session 12, quadratics. Maybe tonight or tomorrow, maybe within the next day, you're going to see the next sheet up. That's going to be next Saturday's live stream, which is going to be 5 days from the exam. Quite crucial. And so it's getting to that crunch time. If you have any questions or you want to choose the topic for next week, let me know and we can do that. I'll stick around for the next couple of minutes if there are any questions, give you some time to think about them, and I'll have some water, which I haven't had much of in the last hour. As I said, just sticking around if anybody wants a question asked. Give you some time to put it in the chat. Or you can suggest what topic you want next. So make it easier for you, I will give you the list of topics that are coming. And if you go to my Patreon, you can see this. I've linked it. There's a little link in all of my community posts on YouTube as well that talk about the schedule. So the schedule is I'll just take a print screen and put it in. Let's go to a blank page. So obviously this is going to need updating. But just did quadratics. So that's going to get a big tick. And I did plan for similarity to be next. But probability is a big topic too. Exact values in trig. Linear equations, that's a pretty foundational topic. Averages, sampling and data. It's definitely going to come up, but it's never worth as many marks as the other stuff. So what do you think? Is there any that I should push forward? Well, time to go. But if you want to push any topic forward ahead of time, because remember, next Saturday is going to be the last before it all kicks off and begins, then let me know in the comments instead. For now, great to have you here, and I hope this really helps you. Good night.